Hi, fourth grade, welcome back. Today we are on Module 1, Lesson 15, and we're going to continue with subtraction today. So, today we're going to use place value understanding to fluently decompose to smaller units multiple times in any place using the standard subtraction algorithm, and then apply this algorithm to solve word problems using tape diagrams. So those are really big fancy words for saying we're going to keep doing subtraction, and this time we're going to keep regrouping until we are able to solve the subtraction problem correctly. You're going to learn to subtract while decomposing to understand how to subtract large numbers. We're going up to the 100,000, so it's really important to know when to borrow and when to just subtract. We will know we're successful today when we can solve subtraction problems using the standard algorithm and then solve word problems with the standard algorithm. Okay, we're going to go ahead and get started. So for problem 1, it says we're going to regroup the units 5 times to subtract. What I'm going to start off by doing is drawing our tape diagram. This is going to help us when we start getting into word problems. So, excuse my really poorly drawn rectangle. Okay, so we have the number 253,421. We've talked about how that number is the total. So when it's the total, it's going to go up top. So 253,421. And we know that we're taking away a portion of it, and we're subtracting some of what we have of our total, so 75,832. That means we're solving for a or a question mark. Anytime it's a variable, doesn't matter. It just means it's a big old question mark that we're trying to solve for this portion. This tape diagram always represents subtraction, and that's really important to know. We're going to go ahead and solve. As you can see, sometimes this almost looks a little lopsided. So if it's easier for you to put it into a place value chart, then please do so, just so you make sure they're lined up. I'm going to go ahead and get started. Remember that we always start subtraction in the ones. We're going to start in our smallest and then work our way up to our largest. So I'm going to start here, and I'm going to use my phrase as always. So if my big number is on top, I do not stop. But my big number is on the floor here. 2 is greater than 1. So I'm going to go next door. I'm going to turn that 2 into a 1 and this 1 into an 11. You can always cross it off, put it up top. But so you go next door and you get 10 more. That's what makes this 1 into an 11. So now I can subtract 11 minus 2, and I get 9. And I'm going to continue this sequence, so you might get sick of hearing it, but big number on top, do not stop. My big number is on the floor, though, here. So I'm going to go next door. This 4 is going to turn into a 3, and that 1 becomes an 11 because we get 10 more. So always add it to the tens place. 11 minus 3 is 8. And I'm going to keep going. I'm going to check every time my big number is not on top. My big number is on the floor. So I go next door. That 3 turns into a 2. And I get 10 more. So that 3 turns into a 13. So now I can subtract. 13 take away 8 is 5. Okay, now I'm here. Big number on top, do not stop, but it's not. My big number's on the floor. So I'm going to go next door, and this process just continues. Make sure you check every single time. I'm going to get 10 more. And so when you check every single time, you just make sure then that you're able to subtract. So now 12 minus 5, I can take 5 away from 12, which is 7. And I'm going to keep going. This happens every time. You cannot go like all the way over. You can't borrow from anything except for the one next door, unless we kind of get into our zeros, which is what I'm going to show you next. So my big number again is on the floor, so I'm going to go next door. My 2 is going to turn into a 1, and my 4 becomes a 14. And then 14 minus 7 is 7. And now I'm here. I have 1. I have nothing to take away. It would be like subtracting 0, so I'm going to keep a 1. I'm going to come over here, and I always go 1, 2, 3 is my comma. My commas are lined up with my place value. So my answer should be 177,589. You can also put that here, 177,589. You could say A equals, just to say that that's what it should be here. And then we don't have it as a word problem, so we're able to move on to our next problem. Okay, so now when we start using our zeros, it's going to be really tricky. So I'm going to start off by putting this one into a tape diagram, and I'm also going to show it to you in a place value table so we can understand why we continue to go over and borrow. So my total is 1,000, and we're going to take away 528. Okay, I'm going to go ahead and draw my place value table. This will not be perfect, but I will try my best. So ones, tens, hundreds. Okay, so I have my ones, tens, hundreds, thousands, and you could keep going, 10,000s, 100,000s, millions. So here I have my 1,000. So I'm going to go ahead and draw that in my purple. I don't have anything in my hundreds place, my tens place, or my ones place, so I'm going to leave it there. Now, when you see this, my same rule applies. My big number's on the floor, but I go next door, and that's still a 0. So I have to go next door, and that's still a 0. So then I have to come all the way over to this 1 before I can start borrowing from it. So just like always, I'm going to actually cash this in for a 0 and bring a 10 over to my hundreds column. So that's exactly what we're going to do with the dots too. Because I need this, I'm going to cash it in, and I'm going to make 10 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, that still doesn't fix my problem because I still need to subtract 8 from this number. So now what I'm going to do, I'm going to keep changing my colors, is I'm going to make this 10 into a 9. And I'm going to cash one in again. That makes this a 10 now. So again, I'm going to cross this one off, and I'm going to cash it into my tens column, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, I still can't subtract 8 from 0, so I have to do it again. So now this 10 becomes a 9, and this 0 becomes a 10, because I'm going to cash in from this tens and put 10 dots in my ones column. 4, 5, 6, 7, 8, 9, and 10. Whew. I'm going to go through with black now and actually be able to solve. So I now have 10 dots, 10 discs in my ones place value. Now I can take away 8. So 1, 2, 3, 4, 5, 6, 7, 8. I'm left with 2 ones. 10 minus 8 is 2. So far it's checking out. Now I really only have 9 minus 2. My big number is on top, so I can go ahead and subtract it. I'm going to take away 2, and I'm left with 1, 2, 3, 4, 5, 6, 7. And that checks out. 9 minus 2 is 7. Now I'm in my hundreds, and I need to take away 5. My big number's on top, so I don't have to stop again. So I can take away 1, 2, 3, 4, 5, and I'm left with 1, 2, 3, 4 hundreds. 9 minus 5 is 4, and I have nothing left in the thousands place. So my answer would be 472, and that's what I would put on this side of my tape diagram. So you see that once you go all the way over and cash them all in and do the process of making it 10 and then borrowing again, it makes the rest of the subtraction process pretty easy. So this time, I'm going to just show you the standard algorithm with this problem, but I am going to still put this into my tape diagram. So we are now subtracting 1 million minus 345,528. So I have 1 million up top, and a portion of this would be 345,528, and that's what we're solving for, is that unknown right there. I know it's really tempting to just go, oh, 8, 2, 5, but remember our big number's on the floor. If you have 0 candy bars, I can't take 8 of them away. So I have to go clear over to this 1, and I'm going to start this process of borrowing. So this 1 turns into a 0. I'm going to make this a 10. but I'm going to have to continue that process. That 10 becomes a 9, so we can cash it in. That makes this a 10 now. And then I'm going to keep going. So then this 10 becomes a 9 because, again, we were cashing it in. This becomes a 10. I need to get it all the way over here, so I'm going to keep going. This becomes a 9. We're going to get 10 more over here. Keep going. It becomes a 9 because I'm moving 10 here. Keep going. This one becomes a 9, and this becomes a 10. Now, some mistakes that I see is that we start to get into this rhythm of borrowing and making it a 10 and then a 9 and a 10 and a 9 because we kept borrowing that process. Don't forget that we're in the ones place now, and nothing got borrowed from this 10. So this stays a 10. We borrowed 10, and we're not cashing it in for anything. Now we can just use the standard algorithm to subtract. So I have 10 minus 8, and that gives me 2. 9 minus 2, because I'm in my tens place, is 7. I'm now in my hundreds place value, and I have 900. So 9 minus 5 is 400. Sorry, 900 minus 500, I should say. So now I have 9,000 minus 5,000 leaves me with 4,000. 90,000 minus 40,000 leaves me with 50,000. And 900,000 minus 300,000 leaves me with 600,000. There's nothing left in the millions place because we had cashed that in to our 100,000s. That gave us that 9, and so on and so forth. So our answer is 654,472. So it looks like a really long process, but once you start to get the hang of it, it really is pretty easy once we know we're going to cash them in. So get 10 more and continue to move through that process. Remember that you can always check by adding these two numbers and making sure you make it back up to 1,000,000. Today I'm going to keep moving though. So now what we're going to do is we're going to use the processes we've been learning, and we're going to use the word problem to solve the answer. So we are going to use the RODW process as always. So I'm going to read the problem, we're going to draw it out, and then we'll write our answer as a statement. So last year, there were 620,073 people in attendance at a local parade. This year, there were 456,795 people in attendance. How many more people were in attendance last year? Okay, so we're going to do a few things. So last year, there were 620,073 people. This year, there were 456,795. Now, they don't want to know the total amount through the 2 years, because if so, we would be adding. Instead, it says how many more people were in attendance last year, meaning they're wanting to find the difference between last year and this year. So my big number, the big number that we have that's our total from last year was 620,073. This year, there were 456,795. And so we're trying to find this missing piece. How many more people were there in the first year? So that means we're going to be subtracting to find the difference. So I'm going to write this down as the standard algorithm. So 620,073. And I'm going to make sure I really line up my place values so it makes it easy and I don't get confused. So I have my 5, my 9, my 7 is in the hundreds, lining up my commas, making sure I'm on the right track. 6, 5, and 4. And I am subtracting, so I'm going to show that. I am going to change colors because I wrote it a little close, so I want you guys to be able to make sure you can see where I'm making my differences at. So we're not using all zeros, but we are going to continue to use the process of going over and borrowing if our big number is on the floor. So I can't take 5 away from 3 because 5 is larger. So I'm going to go next door, make this 7 into a 6, and make this 3 into a 13. 13 minus 5, 13, 12, 11, 10, 9, 8. So 13 minus 5 is 8, and the process continues. Big number on top isn't the case. My big number is on the floor, so I'm going to go next door. Oh no, I run into a 0. So I'm going to continue that process. I'm going to go over one more time. I still can't borrow from a 0. So I'm going to take this 2, turn it into a 1. Now I can make this 0 a 10, but I still have to get over it so I can solve these problems. So that's going to become a 9. This 0 becomes a 10. I'm going to cash it in again, make it a 9 so I can finally make this one a 16. So now I can subtract 16 minus 9, and that gives me 7. And now I'm going to see if I can solve the rest of this. Is my big number on top this time? Yeah, 9 is greater than 7, so subtract that and I get 2. 9 minus 6, I can do again. My big number is on top, so I do not stop. That's 3. Oh no, I'm back to my big number being on the floor. So I can't take 5 away from 1, so I'm going to go next door, make this 6 a 5, and turn this 1 into an 11. So now 11 minus 5 is 6. Big number on top, do not stop, so 5 minus 4 is 1. Okay, I'm done borrowing. I'm done doing all of that. Because it's a word problem and we spent a lot of time on it, I'm going to go ahead and check it. So we just talked about how addition is the opposite of subtraction. So I'm going to check by adding these two numbers and making sure we get our total. So we have 456,795 plus 163,278. Just because these are big numbers, it does take a little bit more time. It's always worth it to check, make sure all that time you spent is worth it. So 8 plus 5 is 13, so I leave my 3, carry my 1. 9 plus 1 is 10, plus 7 is 17. 7 plus 1 is 8, plus 2 is 10. So I'm going to leave my 0, carry my 1. 6 plus 1 is 7, plus 3 is 10. So again, I leave my 0, carry my 1. 5 plus 1 is 6, and 6 plus 6 is 12. So I leave my 2, carry my 1. And then 4 plus 1 is 6, leaving us with an answer of 620,073. That's how many were in attendance last year. So it does completely check out. This was our answer. So we're going to write this as a statement. So I'm going to change it to purple. So my question was, how many more people were in attendance last year? So I'm going to write it so that I restate it. I'm going to say there were, I'm going to plug in my answer, 163,278 more people in attendance last year. So there we go. I read it. I was able to draw it out. And this question mark really ends up equaling that 163,278. I drew it out and then I wrote it as a statement. So those are all of the pieces to solving that subtraction problem. Now it is your guys' turn on your exit ticket. With subtraction, the best thing you can do is just continue to practice, practice, practice. You can see that this first question is written horizontally rather than vertically. Really good mathematicians write it up and down because that's how we've taught you how to solve it. So make sure you put your bigger number on top and then subtract it vertically. Put it in a place value chart if you need to line up your ones, tens, hundreds. That's where I see the biggest, trickiest mistakes. After that, you're going to solve a word problem, and remember to do the entire read, draw, write process for your teachers and for you to show all of your hard work. Can't wait to see what you guys have done. Thanks, guys.